Hello everyone, this is Cerebral Technology Assignment 1. The project is Credit Card Fraud Transaction Detection. Moving with the project, I had loaded the dataset. The dataset name is credit data.csv. I had taken it from Kaggle. It basically contains 31 columns giving the customer's name. Like basically customers are there, only 31 customer transaction values are there, timestamp is there, and amount is there. And at last we have the column class. So class column is having two values, binary values, basically 0 and 1. 0 is indicating that no fraud transaction has happened, and 1 is indicating there is fraud transaction happened. Okay. So moving with the project, I had loaded the some important libraries and libraries for importing the classification models. And yes, so reading the data set, I used pandas.readcsv function, then getting some data, how the data looks like. So we are using data.head. It is giving the top 5 values of the data set. Data.tail giving the bottom 5 values of the data set. Yes, and then data.info. So data.info is giving us the is there any none values and the data type. So data.info basically do this. If we see on the screen, yes, we have 77,338 rows and 31 columns. So there are non-null values and float integer type 64, 464. We have, and for checking if there is any null values, then we want the sum of the null values, like how many null values are there in each column from v1 to v28. We are using this dot is null function, which will be giving if any new null value will be there, and dot sum will be adding those null values and giving the total sum of null values. So we have from v15 to v28 we have single null values in each column. So yes, we will be removing it later. Then yes, like we want to see how I had told earlier the dataset contains classes of 0 and 1. So yes, 0 and 1 classes are there, but we want to check how many zeros classes, like 0 is basically the correct transaction and 1 is fraudulent transaction. So we want to like how many correct transaction had been done, how many fraudulent transaction we had been. So we are using dot value count. So class is the column name, and 0 and 1 are its sub values, and dot value count will be adding that function, adding the value. So we are getting like 77,149 correct transactions, and fraudulent transaction are very less, 180. So yes, analyzing this part of data, this part of code, we are getting like the data set is highly imbalanced. So we need to correct this also. And further I had done like separating the class. What separating, like 0 and 1 were probably like not giving me the much working with the project. So I had giving the class name like class object name, object legit class. So legit class is containing 0 and fraud class is containing 1. So I want to do some statistical operation. So shape, getting the shape is 31 columns in both, but 188 rows in fraud one and in legit one 77,000 something. Now getting the description of each data objects. So legit data object description, getting the stats. So we get count, mean, standard deviation, min, like this. And similarly for fraud one we had done dot describe function. Now here what we are doing, grouping the class. Why grouping the class? Because we want to get the mean of the values. Well, we want to get the mean of transaction amount. Like see here, transaction amount, like what is the transaction the person is doing, what is the average of that. So here we are not getting the person's average, we are getting the class average. Like 0 class column, we have our in data set we have class column. So according to class we are getting the mean of the individual's data, not according to person's data we are getting mean. No, we are getting according to class. Yes, we are grouping by the class and getting them. So observing earlier like the data is highly imbalanced. So here we are correcting it, getting the sample of n equals to 492. So we are undersampling our data. Here we are undersampling our data. So yes, we are undersampled our data, then creating a new data set, concatenating the legit sample and the fraud one. Fraud one is only 188 rows we have, so no problem is there. So yes, we have concatenated it and seeing the new data using data.head, the top 5 values, data.tail, the bottom down values, and then yes, now we are counting. Is our data set is now balanced or not? So yes, the both classes are containing just somehow balanced part data set. So yes, we are considering this. So again, grouping it according to class and getting the mean. The same process we had done earlier for the original data set, but now when we had undersampled it, then the same process was repeated. The next step is coming like splitting it into features and target. We want features and target. What are the main features of our data set and target? What should be the target? So our target, we know that classes are the target. To classify is the transition is 0 or 1 like fraudulent or legit. So it is the target. Features will be other than class. So yes, in new data like see in X values we are dropping the class column. Why? Because our target element is class, not the feature. So giving the column class to Y and getting the features from X value. So yes, X value features like time, at what time the transaction done, V1, V2 are the means persons and amount which transaction done. And similarly see Y, the transaction ID and legit or not legit, these are in the Y. So this is target and this is our feature. The next step is like third step if we talk about is splitting the data set. So we are splitting here data set into training, testing. So testing size is 0.3, which indicates that 30% of the data is split into testing part and 70% is for training part. So getting the shape of the training and testing data set is done with this code block. And here what I have done is getting a list, getting two lists like accuracy and models. So in accuracy, I will be appending the accuracy of each model, and in models, I will be appending the model names. So in here we are going with logistic regression. Yes, so I had imported the logistic regression model and called it, fitting it with training and X-train and Y-train data. Then I want to make our model for training data set, like for training purpose I am using my model. So this code block is for training the model. So for training the model I am using the X-train data, then that X-train data is used for predicting the Y-train values. So, and then we are getting the accuracy for this training data set. Similarly for testing data set we are using the testing data set, then with this testing data set we are getting predicting the Y value. So yes, and this yes, in this code block we are appending the accuracy in that empty list ACC and appending the model name Logistic Regression. Then printing the training and testing accuracy, we are getting like training accuracy is 97, like very high, and then testing data set also we are getting the higher frequency accuracy. So yes, our model was working fine. Then we want the classification report fitted. So this basically helps us in identifying yes how if the model is correct or not. So talking about like classification report, it gives us four things: precision, recall, F1 score, and support. So precision is what? Precision it is like the all positive prediction we have in precision, which means like if the like if I say like high precision is there, so it is indicating like yes there is lower positive rate. Like high precision means come false rate, like low false rate is there. and recall. So talking about recall, like it means a high recall indicating the low false negative rate, and F1 is the mean of this precision and recall. And support is like how many instances of each class at K. Like here we have class 0 and 1, legit and fraudulent 1 now. So of 0 class, like of legit class we have 148 instances, and of fraudulent class we have 56 instances. We are getting this classification report. Similarly, I had imported SVM model. Its accuracy is about 70 to 75%. Same classification report. Same for random forest I had done. You can see the code. Same accuracy on training, testing dataset, appending the model. Similarly, all the things I had done. Just calling the model, training it with just three things we keep by. Calling the model, accuracy of training dataset, testing dataset, appending it, then we are printing that accuracy and getting the report. Similarly for Gaussian Naive Bayes, we are done with decision tree also, just applying the models and getting the and seeing like which model is getting higher efficiency. In classification like CNN we also see about 77 accuracy, like less accuracy was there because under sampling also we have done that. Then the appending one part I had done, so I am printing the models and their accuracy. For printing it like one on one, I had done this function like just zipping in the dictionary and printing it with arrow. Is our like model name and is the accuracy. This is index value like function in dictionary. So yes, we are getting this. Analyzing it, we are getting random forest accuracy as higher. So our whole model is based on random forest prediction. So it is higher. Getting a accuracy chart, a small function of matplotlib I just used, and getting random forest function as higher. So our project is completed with random forest accuracy as highest, which is 0. Which is 95%, 95.5. So thank you.